Hello, I just want to make this video because I was learning kinematic equations and I figured out how to do them pretty simply. This is from NCEA level 2, so this is a New Zealand curriculum and part of that is level 2, so I don't know if this works for level 3 of NCEA or if the same thing works for IB or Cambridge, just as a disclaimer. But anyway, kinematic equations, right? In the exam, you'll be given this as your resource sheet. Now there are 4 formulas that relate to kinematics here. However, there's technically 5, and I'm going to write down 5 of them, and I'm going to show you why. And then there's also so we swap the sign and we make it V final. The reason we've done this, I'm going to get to very soon. Essentially, the way the whole strategy goes is we see what's missing in the equation. In this one, there's no distance. No time, this one, no acceleration, no V final, no V initial. So there's 5 variables. However, each equation only includes 4. Right? You see what you don't have and the one they're trying to find out. And then that leaves you with 3 values you have to know. Right? So let's say they give you time, acceleration, and the initial velocity. Right? They could be asking for distance or the final velocity. If they're asking for final velocity, you know that. Asking for distance, no final velocity, you can find your distance. Alright? So let's just give 2 examples. A skateboarder accelerates uniformly from a standing start at 1.5 meters per second squared down a steep hill. What is his speed 4 seconds from starting? Alright? So, we know 2 things. First of all, the acceleration is 1.5 ms minus 2, and we know the time is 4 seconds. However, I said before, we needed 3 things, right? So the third thing, we got info from the question. A skateboarder accelerates uniformly from a standing start. A standing start means they're not moving, which means their velocity is 0. Or their initial velocity is 0 because they're starting. Alright? And we must find the speed 4 seconds after starting. So V final is what we need to find. Now, what is the one thing we don't need? We don't need distance, right? So we look at the formula. Which formula doesn't have distance? This formula doesn't have distance. We're going to use this formula. And there we go, right? Just by doing some calculation, that's our answer. Okay? So, with that in mind, let's just try another one, just to make it more sense. So this one is from the 2016 exam paper. And if you want to know the standard number, 11171. Alright, so the question goes, Sarah releases a red car from rest down a slope of length 0.5 meters. Okay, we know the distance is 0.5 meters. The red car accelerates steadily and reaches a speed of 1.5 meters per second when it gets to the bottom of the slope. So, the V final, because the bottom of the slope is 1.5 ms minus 1. What else? Then calculate the acceleration of the car as it moves down the slope. Okay, we want to find acceleration. Once again, there are two things, we need three. We got info from the question. It says here it's released from stress, from rest, which means that V initial equals 0. We don't have time. We're going to use this formula, that means. So, let's plug this in. Go 1.5 meters. No, what am I doing? 1.5 squared equal to 0 plus 2 times acceleration times 1 by 2, which cancels out, so essentially 1.5 squared is equal to acceleration. So if I do that quickly, 1.5 squared is 2.25. So alright, so hopefully that kind of made sense. Essentially the steps are: figure out what you're missing, go to the formulas. Oh yeah, when you get the formula sheet, write down this version of the formula underneath it. And then, so change it to V final and change the sign to minus. Then see what things they give, what you're finding, and what's not required. Then use the formula that doesn't have that, and you should get the answer.